All right, here we go. This is the first lesson in Unit 3. Unit 3 is, Unit 2 was big. Unit 3 only has like 6 lessons.
What?
So yeah, actually we'll get through this before the midterm. Yeah, so you have another chance with the unit test to boost it, get your grade back. Here's a reminder. What's the opposite of addition?
Subtraction.
Opposite of multiplying?
Division.
Good. How about the opposite of squaring something?
You square root it.
Square root it. So this last one's a little tricky, but how about this? What's 3 squared?
9.
What is the square root of 9?
8. 3.
No fake answers today.
No. I actually was like not right. I was like,
Yeah?
I didn't mean to say that.
Okay. You misspoke.
Yeah.
So you can see it's the opposite direction. If I had 10 and I added 2, how much money would I have? $2 from 10. Or add 10 and 2, 12. Subtract 2, back to 10. Easy idea. It's just as easy when we're solving these things. You always do the opposite operation to isolate your variable. Okay? And I like to think of it this way. You're working from the outside in, just like peeling an onion. So if I have different kinds of functions here, right, I may need to do, in this one, which one would I do first? If I wanted to isolate x, I'd do the opposite operation to isolate it. Would I subtract 1 first?
No.
Or would I multiply by 2? Because it's
Multiply by 2.
multiply by 2. And we're going to talk about how you know which one to do first. The answer is not always through like PEMDAS. You have to look at it. And you really have to, we're going to make some chains, okay? We're going to make some chains, and you go after the chain that's the furthest away, okay? Because we're working from the outside in, like peeling an onion. If you can peel the onion from the inside out, you're a billionaire.
Wait,
So,
wait, what is that?
Nothing.
Oh, okay.
All right, example 1. So this is the steps. If you're like, I kind of know how to do this. Okay, one second. I want to make some chains here. So what's my variable?
2.
X is the variable.
Yeah.
What's going on? What's connected to X that we need to get rid of? And how is X connected to the 2?
You divide 2 by x.
Good. So it's multiplication going on, right?
Yeah.
All right, how do we break that chain?
Divide by 2.
Okay. So divide on both sides.
So
That's
x
going
is
to cancel.
X equals 5.
This doesn't actually cancel. 2 over 2 is equal to what? 1. So it's a special 1. It creates a situation where we have a 1 times x, and now we just have x. And that's equal to 5. Everyone good with this person?
Yeah.
100%, right?
Yeah.
So essentially, I like to think of these chains because we're trying to break the chains, and then we can isolate that variable. Okay, keep that in mind. So how do we break the chain? What do we do here? Instead of multiply, the chain was multiply. What do we do to break it? Divide. Okay, so think of it this way. And then looking down here, let's make our chains. X is our variable. We want to isolate it. What are my chains? Give me one chain. Plus 1. Plus 1. That's addition. And then
by 2.
divide by 2. Okay. Now, it's an onion. We're peeling from the outside in, right? So if it's on the same level, that's closer, right? Think if you're in a building, X and 1 are on the 3rd floor, right? 2 is on the 2nd floor. You're going from the outside in, so what should we get rid of first? What chain should we break? Okay. You see how it's further away. What if it was 1 plus, or X plus 1 divided by 2 plus 5? What would I go after then?
5.
The 5, because it's further away. This is all combined in one term. This is a whole nother term, so I would go after that 5 first. But that's not what we have. We have this. Okay. So let's break some chains. What should I do first?
Multiply by 2.
It's division, so I'm going to instead multiply by 2 on both sides. You see, that breaks this chain because what is 2 over 2 equal to? 2 over 2? Oh, I said 4. All right, so now we have x plus 1. We still got this chain. It's addition, and now it's equal to 6. I want to break this chain right here. So I'll keep it in the same color.
Minus 1.
Good. It's addition here, so you always do the opposite operation. Look to see what the chain is. It's the opposite, so instead I'm going to minus 1 from both sides. All right, that breaks this chain. Positive 1 minus 1, that is a negation. Negation is when you add and subtract the same value so it gets to 0. Okay, so we got x is equal to 5. Everyone so far so good? You guys have already even done some of this, right? Unit 3 is a little reviewed. You already did all of them. Okay. The last two things. We're going to have to combine variables if possible. If you have the variables in the same equation, all these problems are single variable. We're either solving for y or solving for x. So let's keep the variable positive. Tell your neighbor, what should we do first? Let's get all the variables to one side. Tell your neighbor which side, what should we do? Should we move one term versus the other term? All right. I'm going to start giving points for like talking to your neighbor. We're like
Extra credit?
70 days in, and I think not everyone even knows each other.
Extra credit? Like extra credit?
It might be like a more of like a positive reinforcement. You get like an extra homework point or something.
Ooh.
No, not that kind of talking. You know the talking.
So the answer is like.
So when you're checking with your neighbor, don't just tell them what it is, and have a little.
No.
Did you know?
Oh yeah.
Okay. All right. Let's see, Benicio. What should we do? Should we?
Subtract 3.
Okay. So you want to move the 3 over to this side. Okay. You know what? I would say let's focus on the variables first because I want to decide what side my variable is going to go on. And if we look to move numbers first, we don't consider it.
Add y.
Add y. And is that what you're going to say, David? Okay. Why is it a better option to add y to both sides than to subtract 2y from both sides? Why is the other option, not this one, why is this not the greatest option?
Because it's
Perfect. Cal said it. Negative y minus 2y is negative 3y, right? We want to avoid having a negative variable. It's going to come in handy when we do inequalities, so we don't have to, use certain rules. But I like this. Negative y, positive y, that's a negation. Remember, negation just means we combine values that equal 0.
So they cancel out.
Yeah. So then we get 3y plus 1. All right, now,
Wait, why is it plus 1?
once you've combined your variables, then maybe look, okay, what's connecting y to 3? Multiplication. What's connecting 3 to 1? Addition. Dan.
Oh,
Oh, question.
So basically, did you get 3y because there's the plus y had a 1 in front of it?
Correct.
Okay.
Plus y, positive y, is the same as positive 1y. X is 1x. It's the first one, so you don't say 1, right? It's like saying you have an apple. You don't have to say I have 1 apple, right? It's almost the same way, like in speech.
Like
What?
plural.
Yeah. Like how you refer to a single. You don't have to say you have 1 something. You can say you have
Like
a rock.
multiple of rocks. Okay. Throw X.
Kinda.
Rock, singular, and rocks.
Kinda. Yeah. I'm just saying the rule for singular. Sometimes we don't have to say 1x. We could just say x because it's the first thing. All right. So what chain should we go after?
The 3y.
Well, I want to isolate y. I have multiplication. 3 times y. I have plus 1.
Oh, minus
Onion.
1. Minus 1.
Onion outside in. Right?
Minus 1.
Good. 3 and y are right next to each other. But then we have plus y. I like to think of it this way because we can break the chains by doing the opposite operation. Okay, now we still have multiplication. How do we break that chain? Okay, you guys have 3. 1 over 1. 3 over 3 is 1. Y, we broke that chain. And we get x is 2/3.
But did we basically learn this? We're just doing it like a little bit more, not difficult, but like more steps.
Slightly more complicated. You said what? Where did you get confused?
Aren't you subtracting 3s? So wouldn't that be 2 equals 3?
Yeah. 1 minus 1, 0. 3 minus 1 is 2. Then I divide it by 3. Both sides I get 2/3. Okay. The last thing is sometimes we have to expand it in order to combine the terms. So do you guys remember how to distribute?
Yeah.
6 times 2x, 6 times negative 4. So first we just want to distribute it. And then it's essentially the same type of problem. Oh, wait a minute. I have to change one thing. Let's change this to 11.
Was it because it was the same number?
Yeah. That's no solution. We have that. I just made this one up quickly. Everybody change that? You see 11x?
Why would it be no solution?
Well, because if you eliminate the variable, there's no variable.
Oh, so you can do minus 12x.
Yeah. But what should we do instead? What should we do instead?
Minus 11x.
Okay. Why not minus 12x to this side? It would be a negative. 11 minus 12 is negative x, so we don't want that. That's minus 11x. Negate, because this is equal to 0. So now we have x minus 24 is equal to 24.
Oh, it's not. Okay.
And then what?
Out of size.
Can we just do plus 24 first?
You could, but I want you to move the variable first. Because if you commit to moving the 24 over here, right, then that's saying automatically, by default, you have to move the variable to the other side. Now, having to move the variable to one side might not be the best option. It becomes negative. So move your variable first, and then the default will be moving the numbers to the other side, constants. Okay. So we get x is equal to 48. All right. Not bad, right? We can do this. All right, you guys got 15 problems because some of these go real quick. Thumbs up, sideways, down for just knocking out these equations. All right, that's pretty good. All right, guys, go for it.